We'll directly jump to our presentation, which is practically implementing the test pyramid. Before starting the talk, I want to have a gist of how many people, like what roles are in people, what are the different roles we are having today, like are they QAs, how many QAs we have here? Okay, fair enough. How many developers? Oh, that's nice. Okay. All right. And any other role? Security architect. Okay. Nice. And any other one? Okay.
We manage it?
Oh, that's nice.
Yeah, I do a lot of testing in my project, so I thought that's it.
Okay, cool.
Okay.
That's good. All right. So to give a brief introduction about me, I've been QA since last 12 years. Have been fortunate enough to work on various technology stacks, Scala, Java, JavaScript. So had been a mix of exposure to latest tools and technologies. Fortunate enough to get also to work on various aspects of testing, right from security, performance. Security I'm still learning. It's a vast thing, but then performance, automation, BTD tools. Yeah, a lot of exposure till that. Fortunate enough, and looking forward to have more and to learn more. That's pretty much about me. And how many of you have heard of test pyramid? Wow, almost everyone. Yeah, that's nice. So we don't have to introduce test pyramid, but then I think when we look at test pyramid, it actually hints us to how to strategize our whole test and make us more efficient and go faster, right? So when we look at test pyramid, it's always said that okay, have more unit tests, less of service tests, and then very few UI tests. And that's usually we talk about in normal context. I think there's more to it. If we go beyond, I think what Michael is going to cover is about, again, for the more aspect from UI point of view, where you want to visually test your, test your application, or you might also have to look at maybe analytics. Those things are never talked about, and hopefully today I'll try to do justice to try to point out as many as things as possible which have came to my mind, and maybe this can be just starting step to again evolve this pattern and take it ahead. And to look at it, we have been just hearing mostly about in theories about test pyramid, but then to practically implement it, right? How do we do that? So I have a sample code with me as well, which I've tried mapping it to to break it down and make sure, like, if there's just one end-to-end test, but then rest all responsibility is on the lower base of pyramid, where I've tried pushing down the test to the lower sets of pyramid. So we'll take a look at that as well. So why do we have test pyramid? I think you must have obviously known all these things. Like, we want to have faster feedback. Faster feedback means you fail faster. Once you fail faster, means you're going to fix it faster, right? Or you are going to add more feature faster, and then that means frequent releases, right? And that is true agile for us, right? And when do we say we are unbalanced in test pyramid, right? Any thoughts from audience? When do we say, like, our test pyramid is not balanced?
Repetitive tests.
Yep, that's nice. Repetitive test. Any more?
Like top heavy with UI tests.
Absolutely. I think that's the key, right? Lots of UI tests, right? You want to make sure your UI test will take the responsibility for everyone's, right? For everyone, like maybe there are 10 services, you just want your one UI test to take responsibility for everyone. So is that fair? So that's where we only say that it is unbalanced, because we are putting a lot of responsibility on UI tests. It has its own importance, but then there are other tests which can help take away that responsibility from the UI test, right? So no matter how good your DevOps pipelines are, or no matter how good your code quality is, if you don't have the right set of tests giving you feedback, it's always going to slow you down. right? So you might end up having regression tests for a week for your whole application, right? So do you really want to have that every now and then, right? So let's see. So to start with, how do we address it, right? Where is the starting point? I found it pretty easy for me to look at the architecture, application architecture as a good starting point, right? So which we can use to fix our gaps, right, in our unbalanced tests. So a typical architecture we might see is we have a front end, then it talks to a backend service, like there are a bunch of APIs we have exposed, it talks to that, and those indeed may communicate to a database. So this is like a typical standalone application we might have, right? So imagine something like I've taken an example of a bid auction application where there are a bunch of bids which are going on, and when you click, you get the result who wins the bid, right? This is a simple example. Let's not get into domain of this application, but then we'll just focus on this. So once we click on get results, what it does is it captures the input from the box, and then it will send a request to backend. The backend will process it, right? And then we'll send the response back and we'll display it, right? So we'll display the results. So first thumb rule, if you want to test this application, we don't want to have a lot of, say for example, if I want to validate all this maybe elements on the screen, I don't want my end-to-end test to do that. So first rule is don't delegate the responsibility to someone else, like end-to-end test. Let the responsibility be there and there itself with your model itself. And that's what by hinting, I want to hint is your unit test. So your unit test should, wherever your code is, you'll make sure that you will test it there and there itself, right? So imagine like if this is a building and we want to test whether it has been constructed right. We don't want to have one person to go and check everything. We want to have a specialized person, say the person who has done the flooring we would like him to have someone special with him who will just make sure he'll test everything and he'll just say thumbs up, okay, the flooring is okay. For the electrician, he might have someone dedicated who might just look at the wiring and just say, okay, he's okay. And then as an end user, I might just be outside and just say, okay, can you turn on the lights? If I see all the lights, I might say, okay, I'm good. The building looks okay. So it is something like that. You want to have not from the end user perspective to do everything. You want to make sure you delegate the responsibility to your to your units. So unit or component test, right? So we need to identify the boundaries at each and every layer, right? At front end, what do we have? So we have DOM, which is our HTML, and then we have JavaScript, which will do some interactions or which will capture the response from the text box and will send a request to a backend. Then we might do some styling and make it more beautiful, right? So these are the places where we can write tests. So this is where we are trying to identify what are the blocks where we need to add tests. At backend, what do we have? We have maybe controllers, something like you might say, okay, /get me the username, right? So /username is an endpoint which has been exposed, right? It is a controller which might invoke a function which might say, okay, get me, which might call a function saying, which is my business logic, which might say, okay, get me the users. And the user function is responsible to talk to the database or store procedures and get the response back and send it back again to the front end, right? And do we have only this? Nowadays with modern application, we have infrastructure as code, like we have Terraforms or chef scripts which do the automated deployment. So we need to also think more beyond, and can we unit test that? And there are good frameworks in place now. With Terraform, you can, if you're maybe provisioning AWS, right? You have various plugins of AWS where you can test them, whether whatever Terraform scripts I've written, whether they are working right. So again, this can be again looped into your pipeline, right? And make sure that even your Terraform code or infrastructure as code is being tested at unit level. You don't want to again wait for it to be deployed and maybe someone screws it up and then you get to know afterwards while deployment. We want to make sure we test it right there and there itself. maybe with Kubernetes, right? There are frameworks with Kubernetes as well, where you can check whatever YAMLs you have written, right? Where if you're creating a VPC, right? And whatever YAMLs you have written, if you're deploying in a VPC, whether they're going to work. So you have integration with AWS, where you can check whether this will work, and it will run at unit level. It won't spawn your infrastructure, or it won't, do actual stuff, but it will make sure that whatever configuration you have written is right. And maybe with modern application, you're interacting with third-party tools, like, for example, your Google API. You're using some location search with lat long. You don't really need to test the logic of Google API, right? You have stubs. You can create your own stubs. You can have that running in your pipeline, and just make sure your application talks to that stub. So you can start thinking of stubbing your responses, or if it is serverless, or maybe S3 bucket, you want to write it to S3 bucket. You don't need to really write to S3 bucket. You can have a unit test which can just use a mock library from AWS and integrate that. And without actual writing to S3, you can just get a feedback whether you're consuming the right APIs. And those mocks are pretty updated, and whenever you update your, say, NPM modules or anything, you get the latest one, right? So you can always identify the boundaries and just check the feedback. Whatever logic you have written, you can just test it at unit level, right? And we'll take a more detailed look to it by looking at the code, but then this is just to brainstorm about. And is that all? Like, we have even more, right? You can also have security, right? So if you are having more security aspects, you can even unit test that, right? With pre-commits, you can have your maybe make sure you don't check in your, say, for example, if you're trying to check in your secrets, right? You can have your pre-commit so that you don't do this mistake, right? So these are the feedbacks you can have at there and there on your local script, on your local machine, and those bugs can be avoided, right? And your static code analyzer, which can check, right, is your code, is your formatting right, or is there a better way to write it, or can you efficiently write it? Your static code analyzer can do a code analysis and give you a report at what are the best practices, right? So this, I think, are to be considered at unit level, and that can give you a lot of value, right? So I can quickly show you some code which can give more insights about that. So we talked about this application which does some beating, right? So if I have to maybe show it, so if I have some bits going on, if I click on get results, I have some response from my backend, right? So if I look at this application, it's a simple HTML application. Is the code visible back? No? Is it visible now? Okay, so I have a sample application where there's HTML. We talked about the first layer, right, which is the front end. We have an application which is nothing but just a bunch of text boxes and a button, and then it has a JavaScript which does a post call to the backend, right? It calls a slash process endpoint and does a post call. That's it. And then once it gets a response, it actually binds it back to the HTML. So if we look at the unit test, how simple it is. So I have used a tool called Cypress. It's not ideally for unit testing, but I've just done a workaround to just show that what can be a unit test look like for your front end. And I think this is the major chunk. So if I try to run them, it is actually trying to input some values and trying to check. So if I run through what are the tests, it just says if there's a header, if I can pass inputs to it. If I scroll down further, it checks there's a button, and that's it. And I also have one more JavaScript which actually tests like when I put in some values, I've mocked the responses. That's where I was saying like you can start mocking your responses and check whether my JavaScript. Sorry about that. So I can check whether my JavaScript is actually working. So it just checks, like here you can see there is a dummy response, but then my actual service which is running, right, is actually returning me a exact response from my backend. So if we want to quickly look at how we can do it is, these are my bunch of unit tests. So it just verifies the DOM, right? Whether those elements are getting visible, right? And at start, I'm also making sure that my results are not getting displayed. Furthermore, when I actually try to, so this is a way I can mock my backend service. If I switch off my API, right? This test will still run because I'm just unit testing my JavaScript. So here we are just setting the value and doing a click event and then waiting for a response. And what it does is it just displays my mock response, which is this. If I want, I can change the value to anything saying, and then it should still work. If I go back, it has picked up my changes. And yeah, you can see that it has updated. So that's, if we look at our slides, so if you look at our slides, we have covered this part where we are testing a DOM separately with unit tests. We are testing a JavaScript where the interaction between the UI and the backend, when whatever processing is being done by the unit test. CSS part, I think Mikhail is the right person to cover it in our next talk. He's going to test the visually our UI. I think his topic is going to cover that, so I'll leave it up to him. And I don't have anything to show as well for that. Maybe next time I'll include your test.
Perfect. Yeah.
Okay, now let's quickly look at the backend, right? How does the backend look like? So this is a simple Spring Boot application where we have main, where we have our source code. Let me try to zoom in. Come on.
Otherwise, you can go to preferences, and then you have to go into editor. There should be one setting, font.
Forty.
Yeah, just you can change it there. Yeah, enable font.
Which one?
Yeah, it doesn't work. Yeah,
Okay,
yeah,
all right. Cool. So if you look at it, the structure is like you have your main and your source code is in main and all your tests are here. So it is actually replicating the exact structure. Like if I go in, it will have similar paths. If I go in further down, yeah. So what you have is the controller where the endpoint which we are calling, right, /process. It is actually trying to call some internal logic of the domain and trying to process it, and then that's it. So your endpoint is defined, and it is supposed to call some of the functions which we have written, right? So it might need to say parse the record, and then it might need to process the auction from the auction house, right? So if we look at it, we would ideally have a unit test for a controller, which will just make sure, like, whenever the input has been passed to that function, right, we are just checking whether those methods are getting invoked. So we are just checking whether the mapping is right or not. if we go further down, like whether just checking like if this mapping is right. So if when I call this when I call this function, whether it is calling the functions or not. So this is if I go back to the slides, right? I don't have any actual representation of it, or maybe we can look at this one. So when it is calling the endpoint, it is supposed to invoke some business logic to it. So we are just making sure that the right business logic has been called. That's the only motive we have. So because this can be misconfigured, right? So tomorrow, for example, if someone changes it to maybe processes, we need to know it right on on our machine itself if I accidentally introduce a change, rather than waiting it to be deployed and someone and our test integration test or some other test which would catch this error. We wanted to make sure that the feedback is caught on our own local machine, so that it doesn't, we are trying to reduce the feedback, right? So going further, everyone knows unit test, right? So this is something like, for example, for this logic, right? I have option map. Yep.
Okay, so question.
Yes.
How important is alignment on the tool set
I think it's
within the team before you?
a tool set depends on the tech stack you choose, right? So if you are choosing Java and Spring Boot, ideally it's better to go with Java, right? Like with front end, you have a lot of options. With front end, it depends. Like if you're using Angular, Angular has its own test bed setup. It's recommended to go with it because it is easily integratable. You can easily integrate it. I was using a simple HTML, so I just used Cypress, which was much more easier choice rather than, because Cypress has Mockito and everything integrated. I don't need to explicitly go ahead and set up the whole tool set. So nowadays Vue has a good integration. It actually binds up all your Mockito or other JavaScript frameworks which are helpful to do unit tests. Like if you want to spy, like what we did was to spy on a method which was getting called and just mock it with some arbitrary response to make sure it works. So when a post call is happening, we are just blocking it and we are just checking whether it works, and we are just giving it a dummy response and saying. So tool set is all on your tech stack. So you choose any modern tech stack, you have really good support. You just go to your testing testing section, and you will have all this information. So this is pretty generic. We are trying to cover so that you can go back and whatever tool set you have, just go back and check the testing section, and it will relate. You can relate to it. So that's why I'll share this on GitHub as well. So tomorrow, if you want to do something, and even if you pick up the keywords and do a search, you'll still be able to find it. Thanks. Any more questions? Feel free to interrupt me in between and ask questions.
Is this common for folks here? Is this bleeding edge? Okay, raise of hands if it's bleeding edge. Good. Common? Okay.
I would say the approach is fairly common, but I think I like the approach from the perspective of being agnostic. You're applying the right tool to the right context. Like at the moment, I'm migrating my Jeb test to Nightwatch, and in Nightwatch, because it's primarily a front-end JavaScript-based Selenium-backed sort of framework, it doesn't have the same sort of JVM tech that Jeb has.
Right.
So I'm having to come up with different
tools and try to integrate
so
or come up.
how do I bring the Wiremark server into the thing? But absolutely. I like the way you presented that.
Oh, thank you. So further going down, once we look at, like we have checked our controller, now we want to check our business logic, right? So you might end up creating some libraries or utils, like I have done over here. Like in utils, I have some formatters or inputs, right? Passing the inputs. So I have one-to-one mapping where they are like public functions, right? So for public function, it does make sense to have a unit test. If you don't have a public function, feel free to skip it because it would be covered by some of the other unit tests up on the, you know, up in your architecture. Like whoever is using this input file will be able to, test that. But then as they are public, I'm actually trying to write a unit test for it. So if you'll see, I have a unit test for that as well. So it depends on the strategy as well. So if you're using TDD, right, what we are trying to do is a bottom-up approach where we are trying to identify the units and then write the test. But if you're using TDD, this upfront design, if you have a high-level view, it also helps because now you know where to start. So if you want to start your TDD right from your APIs, right? This whole, the test would be much more optimized because the feedback from TDD will help you to identify your test. So it depends. You'll start identifying your behavior and start implementing that, right? Here, till this point, I had done it in TDD where this was an console application, but to move it to a web application, I had to just integrate it with Spring Boot. But then if you'll see all the tests, they automatically evolve based on the feedback. So whenever I actually created a utility, I could actually, this was one test, but then if there's more logic to format or something, if we'll look at the test, there would be more tests, right? So it actually falls in place if you use TDD. So I would recommend highly that start practicing TDD, even if you start from UI, like a few of the companies start by writing a Cypress test or maybe an end-to-end test and then drill down for the deep pyramid. But then I would recommend you guys to look at the TDD approaches and how the TDD has been done. So this is to cover up this section where, if you have libraries, you would ideally add unit tests for that as well. Maybe for stored procedures, you might look at, so if you have a legacy application, if you're using stored procedures, you also have unit tests for that. So maybe worth looking at it. So your modules and components are totally contextual, right? So if you're using, you can consider your API as your module and you can start writing tests from there if you follow TDD. If you're following a bottom-up approach, you can directly look at the library if you're thinking upfront and if you have identified your components. When you started implementing, you can directly start with unit tests and then write your code with bottom-up approach, TDD approach as well. So that covers up most of the unit level things, right? Yes?
You are a QA or a developer?
I'm a QA.
Do you write the unit tests?
It really depends upon your team understanding, but I would ideally expect a developer to write it because he's responsible. So when we talk about unit testing, we say the responsibility should lie there and there itself. So if you're responsible to write the code, maybe you should take the responsibility. Maybe I can assist you, I can help you to identify the gaps. So when from requirement point of view, if I think, oh, there is a gap, we need another test for this, maybe I can assist you and say, okay, I can give a feedback saying when we can go through all the tests you have written, right, as a developer, and then see, okay, whether this has been covered, whether a business scenario has been covered at some or the other level. So that can be a good approach to have a collaborative interaction between a developer and TD, and we can always step into each other's shoes. So if, say, there's a lot of load on developers, maybe a QE can or a QA can pitch in or help you to write the test.
I mean, some people prefer writing their own units because that helps them to develop better.
Yes.
Or even be better.
Absolutely.
So I have come across some developers where they write the unit tests. So that's why I was just confused.
No, I just wanted to consider a sample application so that we can just walk through it. But it should be, I think, it should share responsibility as well. But then I think developers should primarily own the tests. So we can look at further, if we go down further, like what is the second thumb rule, we can start looking at the integration points, right? So where our system is talking, to which parts our system is talking. Like initially I said it was simply a standalone application. Now imagine you have furthermore requirements and you're integrating with furthermore aspects, like maybe a S3 bucket, you want to write it to S3 bucket, or maybe you want to invoke a Lambda function, you want to make it serverless. You have just a front-end application which might just invoke a Lambda function, do some processing and give you back the results, right? You want to make your UI as light as possible, right? Or maybe you're interacting with third-party applications where, like Google API, right? So that can place. Or if you have an in-house API team or if you have a huge team and you have chosen a microservice architecture which is distributed across various teams, then you might have to think of how you are going to have your testing strategy or integration test or your integration strategy for your test, right? So one thumb rule would be, if you're responsible for your own Lambda function, maybe it's better to invoke that and check the feedback rather than stubbing or maybe abstracting that boundary, right? So if you say, imagine you have a application which is just processing some data, right? Or you're triggering an action which might process your videos overnight, right? Ideally, you would like to invoke that and check the integration if you're responsible for that. And maybe S3 bucket, I really don't need to care. I can just stub it or I can just mock it, right? I don't need, because it's a third-party API and I don't take the responsibility for it. I know it's going to work. And for third-party services which are not in your control, like Google API, you can just stub it. And for that, there's another thing, you might have to cover it in your pipeline. Maybe I'll come to it. It's called contract test. So that way you can make sure that at least your API is always working and they're never broken, whichever you're consuming, if you don't have control on them. And if you have a control on your own services, you can have something called as PACT, which is, or your contract test. So PACT are consumer-driven tests. We'll cover them maybe in further slides. But then, yep. So these are the integration points you can look at it. If I look at my sample application, I have an integration test which is out here. So I have an integration test which calls my application and then checks what response I'm getting, right? So if I try to run this, maybe the best part is to show you through a console. I think I didn't show you the end-to-end test as well. So this is how the end-to-end test would look. It is actually going to invoke and send some request, and on click of get results, it's going to give me results. So if you see here, it has actually done the request. Whatever previous test, which we had looked at unit test, right? Which we already saw, right? Here it shows there's a request, but it shows it's a stub one, right? So, and then with integration test, so if you'll see the total time to run this one end-to-end test was 2.51 seconds. Most of it was for typing, but imagine you have a huge application and you're testing everything. So your feedback can be hours or sometimes can be, maybe days as well. A few tests I've seen, the feedback was literally a day. They had to wait for all the tests to result for a day. And these are more realistic, right? When you're actually seeing the user actually typing, so you know that your UI is going to work. And if you see at the previous one, so your end-to-end, that was your end-to-end test might take much more time, all right? And your unit test, if you'll see this one, it hardly ran and validated everything in matter of seconds. So this test literally ran in matter of seconds, this set of tests, right? And if we look at the integration test, I'll try to quickly run my whole application. If I run my test, the feedback, look at the feedback, how fast it is. All my business logic has been validated. This is their starting time, but it was literally 6 seconds, out of which most of the time it was maybe trying to bring up the server. So if you see here, it has actually brought the server up. And so maybe I can just run my unit test. Yep. Okay. So it is actually bringing the server up, and okay, there's a failure. Okay, why is it? Okay, because there was some error in my response.
Abhijeet,
Yep.
we are loving this, but I'm mindful of our guest speaker.
Yep.
Is now a good time for me to basically say over to Mikhail?
Or maybe just 5 minutes. I'll quickly, because this was the main part, showing the demo.
Just a reminder.
Yep. Okay, so most of the stuff we have already covered in while doing the demo, like with various integration. But then the only thing which is left is how do we scope it, like where you exactly done. So if we look at it, this might look like a good process for us. When we want to push a change, we pull it, we run our unit test, we run our integration test locally, so that whatever errors we have done, that we can catch them locally, and then run our pre-commits and then push the change. Then further pipeline can look like once we push a change, our unit tests are run, our static code analyzer runs, visual testing is also run during build time. We deploy it to dev, and say imagine if we have an API like Google, we stub it, and then we run our integration test and end-to-end test, so that we know that thing works exactly in our whole ecosystem, and we are just cutting it out from our external dependencies like Google API. And then the only thing we can do is we can add a contract test which can just validate by hitting one request to Google API and check whether that works, right? This way, instead of having it, our application call it 100 of times for every test, it's just one. If you're consuming 1 or 2 APIs, you can just add that as a contract test and make a real call, a REST call to a Google API and then test it, right? And then you can do a further processing of deploying it. If you have further complications, like if you are having a microservice architecture and you have various dependent tests, then that's where the contract test can come in place. Where, say, if you are a consumer service, like for example, maybe you are responsible for, say, developing, you're just lat long location and you want to fetch, and you're dependent on, say, maybe, or you're a Twitter and then you have a downline dependency of, say, maybe fetching the customers information, right? So what you can do is instead of actually mocking it, or instead of actually invoking the APIs, your test can publish a contract to a test broker, and then that test can be run by your pact, which is your dependent service. And once they verify your APIs, so this is all, say you're a consumer, and then maybe you don't want to verify it. You are just taking your own responsibility. You will make sure your unit tests are running, your integration tests are running. But when your integration, you're not actually calling the API. What you're doing is you're just generating a response you're expecting from your dependent service, and you're giving that API to your your dependent service, and just tell them, okay, this is the response I'm expecting, whether this is valid, just let me know. And what they'll do is they'll run your test and they'll return you the results whether they're okay or not. And based on that, you can do the further deployment. So it's just that your dependent service is giving you a confirmation, I haven't broken your contract, right? And similar thing can happen when there's a change in dependent services. They can pull all the consumers who are running the test, their expectation, run those on your local, on their local, and just tell them, okay, I haven't broken anything. If they broke anything, then it's the two communication teams who have to take care and then do further deployment. So going down further, you can also have integration of analytics, performance tests, security tests, and further metrics. So maybe it's not limited to that. Even after doing your deployments on your production, you can have integration with various, you can track various metrics, how the users are using it, whether there are any errors, you can capture those and you can have alarms based on that. So all you need is just a high level, like a upfront design, think forward, do upfront design, identify who all are your dependent and dependent services, and maybe then there's a small change in cultural shift and you can still achieve continuous delivery. So like with maybe early seconds, you can, in maybe 10 seconds you have verified the whole application, right? So you can do a continuous deployment even to production if you have a good feedback cycle. So that's pretty much it I had to cover. Any questions? No, I'll quickly hand over to Mika.